life-saving intervention on a patient. They are in a critical state and need to be connected to an ECMO device which supports their heart and lung function. The procedure contains several steps which need to be carried out accurately, and complications can occur as well. You have performed the procedure twice in your life. The last time was 6 months ago. Your last training session even lies back more than a year, and your only support in the operating room is a 5-page printed document. Quite exactly 9 months ago, we as a team were confronted with that situation and given the task of bringing augmented reality into the operating room to benefit ECMO implantations. We are Aurora, and we have developed an augmented reality operating room assistant. With the help of HoloLens 2, we provide surgeons with assistance and information where they need it, directly in front of their eyes. The intervention we are creating our application for is the ECMO implantation. An ECMO, short for extracorporeal membrane oxygenator, is a machine which provides cardiac and pulmonary support. When connected to the patient, it pumps their blood, removes the carbon dioxide, and then oxygenates the blood again. What you need to know about that procedure is that, especially in smaller hospitals, it is not carried out on a regular basis. Training opportunities are time-consuming and therefore very limited. So surgeons can go months without having to perform an ECMO implantation and then suddenly be confronted with an emergency situation. This is why we provide simple training opportunities, assistance for preparing surgeons for real-life operations, and eventually also support in the operating room. The gadget enabling us to do so is the Microsoft HoloLens 2, a pair of augmented reality glasses. Cutting-edge technology allows us to project 3D objects directly into the room, where the surgeons need it in their field of vision, but without blocking their view. It is our vision that our operating room assistant enables for a better future for ECMO implantations and training. Therefore, it should be able to simplify training opportunities, support surgeons, and optimize processes where time is precious. So let's see where that vision has taken us. Two main sub-applications and various additional features as well. We did not only want to implement an application, but also explore the features provided by augmented reality and get proof of concept for some of them. So our first sub-application is a standard operating procedure which guides the user through training. Computer vision there allows us to analyze and detect the tools used for the procedure. And visual guidance is given with video and 3D material so that the surgeons get support where needed. Our second sub-application is a troubleshooting guide, a tree-like structured application helping with simulation-based training and supporting surgeons in problem-solving strategies. There, visual guidance is given with 3D animations which help the user to solve problems related to the ECMO machine. Data tracking allows us to track the data, detect problems, and then generate specific warnings. So, now that you know about our background and motivation, without further ado, I will take you on a tour through our application. Starting the application, you will directly get to our main menu, where you can choose which part of the application you want to access. First of all, we'll take a closer look at the standard operating procedure. There, the user can decide between 3 levels of difficulties according to their know-how and experience. Those levels differ in detail and display of information. For now, we're going to do the beginner version. The first page the user gets to is our Check Tools section. There, they are asked to place tools in front of their vision, and then let's have a look at this. So the tools are placed on a table. By saying check tools, the whole process starts, and the computer vision algorithm detects the tools and analyzes whether they are chosen correctly or not. Then they are marked with those tool tips so the user can see which ones are correct and which ones are not. They are then listed here. This is especially useful as it is also an essential part of traditional ECMO training. Having chosen all tools, the user gets to the main part of our standard operating procedure, which contains all steps and all information needed for those steps. For some steps, there is even additional support material, such as 3D models, videos, or images. Here you can see a 3D model, which helps the user to gain more spatial awareness about a certain step. And the video, if clicked on, expands to full size, and the user is then able to start and stop whenever needed. They can even go on with whatever they're doing during the procedure as the video does not block their view. There might, of course, still be some uncertainties about the step, so the user can simply mark the flag symbol and the step will be saved for revision later. Of course, surgeons may have their hands full during the operation or the procedure in training, so they cannot always press the button physically with their fingers. However, we have implemented voice commands, so they are able to instead just add the word Aurora in front of any button and can then click the button like that. So for example, if I want to go to the next page, I can simply say Aurora next. Having done all steps, the user is provided with statistics to assess their progress. They can see how much time they have taken for the whole implantation, how many tools they have chosen, and how many flags they have marked. There is even more specific statistics in the buttons provided on the right. Additionally, a PDF document containing all of those statistics is automatically generated on the HoloLens and then available for download on your computer. The user can easily compare their run with previous ones or even to hospital guidelines. Like that, they can estimate whether they are ready for real-life procedures or not. So now that you have seen our standard operating procedure, Vincent will take you on a virtual tour through our troubleshooting guide.
Exactly. So the troubleshooting guide is the second part of our application and provides surgeons with simulation-based training opportunities. Moreover, if we would conduct the necessary clinical studies, it would also have the potential to be used in actual ECMO procedures. So let's take a look at this. When activating the troubleshooting guide, the surgeon is always provided with 4 buttons to the left of his field of view. If any problem then occurs during the operation, he can simply click on the troubleshooting option and specify his problem step by step. The surgeon is then provided with a suitable solution to his problem, and in some cases can even activate a 3D animation that illustrates this. So here you can see the removal of the oxygenator in the case of oxygenator failure. So the second feature with which we wish to support surgeons is the display of patient data. If the surgeon chooses this option, he is displayed a heads-up display that provides him with basic patient data as well as signals from the ECMO machine and even visualized data such as the ECG curve. So for us, it was very important that we would give the surgeon the opportunity to view all the data necessary to his decision-making in one specific location. And for this, we originally planned to connect all the necessary devices to a server and there process the incoming data and check for potential complications. We would then forward the data together with potential warnings to our HoloLens where they would be displayed. Unfortunately, due to the pandemic COVID-19 outbreak, we had to return those medical devices to the University Hospital of Zurich and instead came up with an all-in-one server application that doesn't just process the data, but that simulates the data by itself. And this is actually quite handy during training because now an instructor can simulate any kind of training scenario, set every data point individually, and issue every possible warning. And the trainee then can respond to this warning. And this is what we mean when we talk about simulation-based training. Now, as I said, the application also checks the vital parameters for possible complications. Once such a complication occurs, a warning is displayed on the HoloLens, clearly visible and also with an acoustic signal, and the surgeon can respond to this warning by clicking on it. He's then led to the one place in the troubleshooting guide that is most specific to resolving this warning. We've also been working on an advanced version of this warning system where we make use of the incoming stream of vital parameters to highlight the most relevant and most probable causes for the current warnings. So now you've seen the step-by-step guide, which provides surgeons with education on how to implant an ECMO. You have seen the troubleshooting guide providing a simulation-based training opportunity and the potential to support surgeons in the future. So what remains is a number of features that we explored and which we are proud of, but that didn't quite fit into the remaining concept of the application. And those features are collected in what we call the toolbox. One example for such a feature is what we call the tool direction indicator. And here we make use of an external camera that also features a depth camera and make use of this camera to analyze the surgeon's surroundings to localize a certain tool of interest within this surrounding. We then use the position information of the tool of interest to display a white arrow on the HoloLens that always points into the tool's direction. This is just a simple assistance feature. In this feature, we make use of static tool recognition. So what we do is basically we run an object detection algorithm over every single frame to localize the tool of interest on the frame. However, we've also set ourselves the goal of achieving dynamic tool recognition. And with this, we mean a system that can recognize tools as they are being held in the hand of a surgeon and therefore occluded and moved and suffer from those kinds of distortions. So why is this useful? If we would be able to develop such a system, we could, for example, use it to estimate whether or not a tool is currently being used. And this in turn unlocks a whole array of possible assistance features. For example, you could record the order in which tools are being used, and because this order is relatively well defined in the case of an ECMO implantation, you could issue a warning if the surgeon uses the tools in an unusual order, thereby suggesting that he might have missed a step. So that's why dynamic tool recognition is important. So how did we go about in implementing it? Our idea was to combine two things. First, object detection, which makes use of the visual characteristics of a tool to localize it. And secondly, object tracking, which basically follows the movement of a tool on the camera frames. Our idea was to run object detection once in a first frame, and then in the subsequent n frames we would just follow the movement of the tool with the help of object tracking. We would then repeat this cycle on and on to allow for a more robust system where we make use of both the visual characteristics of a tool and the movement information provided by the camera feed. Now, this worked to some extent. Our new system was more robust to some kinds of movement and some kinds of occlusion. However, it wasn't yet quite advanced enough to use it for tool usage estimation. However, we were able to incorporate it into our tool direction indicator feature. So this sums it up when it comes to all the features that we explored in our project, and now is the time to reflect and take a look on what we achieved during those past 9 months.
So, even though the COVID-19 pandemic prevented us from conducting a systematic usability study with many subjects, we still managed to conduct 2 smaller studies, including 4 surgeons each. We conducted a usability studies where surgeons were given 30 tasks to complete on our application on the HoloLens. The tasks were then divided into 4 main categories. The green ones were the tasks done in a certain time. Then the yellow ones, the tasks done but exceeding that certain time. The orange ones were the tasks completed but only with help. And the red ones, finally, are the tasks that could not be completed at all. As you can see here, in both of our studies, we've managed to have more than 75% of the tasks completed, which indicates quite a good usability. We have worked on our user interface and the handling of the application between the first and the second study. And as in the second study, there are even more green tasks. This might have really brought some improvement. So after having completed the tasks, the users were asked to fill out a system usability skill questionnaire, which is a standardized questionnaire for usability studies. The final score lies between 0 and 100, and we have managed to get a point score of 85 for each studies in average. This corresponds to an excellent usability. As you can see here, the box plot in the second study is a lot wider spread than the first one, and this might be explained due to the fact that in the second study there was 1 surgeon involved who never encountered augmented reality before, and 1 who has already worked several times with our ARORA application. So, did we live up to our vision? Simplified training is given through our whole application. It allows the user now to go through the training process on their own and enables unprecedented simulation-based training opportunities. It all in all simplifies ECMO training significantly and therefore paves the way for more frequent training. Support is given by various features in our application. Our text tools section, for example, enables us to detect and analyze tools and enables the surgeon to easily choose the right tools. Additionally, the troubleshooting guide structure enables the user to easily find the right solution and therefore supports them. Optimization is given in simulation-based training and in the generation of warnings. Being able to simulate a variety of problems allows for realistic training and therefore optimizes a surgeon's preparation for the real procedure. The generation of warnings linked to possible solutions really optimizes the problem-solving concept and process to a large extent. So all in all, we can say that we have reached all of our main goals, and we are optimistic that our ARORA application will simplify training and make a huge improvement in the world of ECMO implantations. However, there's always room for expansion and improvement, so Vincent will now talk to you about possible future scenarios.
Exactly. So one thing that would be quite interesting is to make more use of those vital parameters that we measure. So for example, we could think about using machine learning and maybe even other data science methods to analyze the incoming vital parameters and try to even predict complications before they are occurring. This would, of course, give more reaction time for the surgeon. Now, as you've seen, we currently simulate our data on our server application. So to complete this data pipeline, it would still be interesting to connect the ECMO device and other medical devices to our server application so that we can display real medical data to the HoloLens. Now, the last step in actually bringing our application to the operating room and making an actual difference would be to conduct more clinical studies, meet the necessary regulations, and then let our application benefit ECMO implantations and ECMO training. So on this note, I would also like to say that this entire project would not have been possible had it not been for the generous support of both our sponsors and our partners at ETH and the University Hospital of Zurich. During the past 9 months, we, as a team of 7 students, have had the amazing opportunity to explore different augmented reality features for the medical theater. And this was very interesting, and we are quite convinced that augmented reality and this machine-in-the-loop kind of idea makes an actual impact in medical procedures as well as training. So we are extremely excited to continue to observe how those opportunities evolve as holographic devices become even better and even more precise. And on this note, I'd also like to thank you for tuning in and listening to our final presentation. Thank you very much.
Up next is a live demonstration of our ARORA application, but we need 2 or 3 minutes to set up, so we'll be right back. Live demonstration of the ARORA application. Marcel, to my right over here, is going to be performing a step of the operation using our app, and you will see what he is seeing through the HoloLens. You can see here he's getting ready for the operation by making sure he has all the instruments he needs. He is doing this by using a table overlay, which has boxes for all the tools needed and a picture showing you which ones. He can now see that he's missing the arterial cannula, so he places it in the box. Next, he has to choose what he needs for the next step. He has 2 cannulas in front of him, but he's unsure which he needs, so he's going to use our computer vision feature to check. He's just used the voice command. And you can see here that the limb perfusion cannula has been marked green and the arterial cannula red, which means the limb perfusion cannula is what he needs for the next step. He can now move on to the operation itself. He's going over to the mannequin and placing the window in the place where it won't get in his way while he's working, and can now begin. He starts by watching a video on how to perform the arterial puncture. He can now take the needle and perform the puncture. You can see there is a directional indicator bringing his view back to the window in case he forgets where he left it. And you can now move on to the next step, which is inserting the wire through the needle into the patient's artery. The wire is now successfully inside the needle, which means it can be threaded into the patient's artery. This is needed so that the cannula can be inserted over the wire into the patient. You can now move on to the next step, or continue watching the video. He's now seen what he has to do, which is remove the needle. And he can now proceed by inserting the cannula into the patient by threading it over the wire. The limb perfusion cannula is now inside the patient's artery. And you can now move on to the last step, which is connecting this limb perfusion cannula to the main arterial cannula, which ensures that the patient's leg is perfused with enough blood. Here he watches another video on how to do so. And is now connecting the cannulas. This was the last step of the operation, so you can now imagine that this is some time later, and the patient is on the intensive care unit, where problems often occur. You will see here that a warning is about to pop up, showing that there is low blood flow to the patient. He can simply click on the warning and is now suggesting that the oxygenator might have failed. To remedy this, he's clicked on the 3D animation, showing a 3D render of the ECMO device with instructions on how to change the oxygenator. He's now clicking through the animation, and you can see that he needs to clamp the tubes leading to the oxygenator to change it. And you can see that he can now use the latch on the side of the ECMO device to remove the oxygenator. The next step would be to replace this oxygenator with a new working one, which you can simply click into the ECMO device, as he saw on the animation. Hopefully the patient is now stable, which means we can now move on to our round of questions here in the room and on the live stream. So if you have questions, please write them in the chat. We'll have someone reading through them and posing them to the room here, to Vincent and Vivian.
Yes, please. Thank you very much. Oh, sorry, she has to come with the microphone. Forget to say.
Thank you very much for the presentation. I was wondering, so you have developed all these different features for the specific case of the ECMO. How easy would it be to transfer the individual features to, let's say, a completely different scenario or different intervention?
Mm-hmm. Yes, well, there I can say that, I mean, a vast part of our application isn't really limited to being used for the ECMO implantation. For example, if we look at the SOP, the step-by-step guide, you could there fill in any kind of text for any procedure pretty much. You would just have to exchange the text and the media files, and then use the same kind of step-by-step guide for other procedures as well. The same goes for the for the troubleshooting guide, so you would obviously have to exchange the text of this tree-like troubleshooting guide structure so that you have a troubleshooting that is specific to your procedure of interest. And but I mean, the main concept of guiding a surgeon through a procedure during training with a step-by-step guide, and then helping me in during an actual procedure with a tree-like troubleshooting structure, can be in theory used for any kind of procedure, so it can be generalized.
Yeah, thank you for the presentation. I'm curious, so you explored a lot of possibilities and features with the HoloLens. So there are some features like displaying the videos. It's convenient to have it on the HoloLens and not on the external monitor, but there are certain features which are only possible with augmented reality and the HoloLens.
Yes.
And I think it's clear to have everything in one tool. So can you comment a little bit on the unique features which are only possible with an augmented reality?
Yes. So as you said, in a general sense, the HoloLens really offers the opportunity to have everything in one single place. So you wouldn't have to look at different devices, but you can display everything with this one software, which is very nice features. But when it comes to augmented reality, what is particularly appealing and can in this way only be done on a augmented reality device like the HoloLens is, for example, 3D animations. So you saw that we can really animate whole devices, whole movements very easily, and can therefore illustrate solutions in a much more appealing and much more visual manner than we could with, for example, just a piece of paper or another medium.
The second question. So on the training, you showed two approaches. So the one way is that you have so defined areas, and you know in which area which tool is. You lie the tools at the right position, so you don't have to recognize. You only recognize the position. So this is one approach. And then you also showed that you can ask Aurora what tool is it, and then you get the information with image recognition. Can you how complex so it's running on the HoloLens or it's running on the server? Can you comment a little bit how this object or the picture recognition works, and how stable and fast is it? So there was a slow delay. So
yes. Yes. So I will answer this question again because I was a member of the computer vision team. It was quite difficult to get this running, and we had several approaches in the beginning. We wanted to do the computer vision algorithms. We wanted them to run them on an external server. But in the end, we came up with the solution of training a neural network with a tool of Microsoft, actually. And this was then quite easy to implement on a HoloLens, but it does run relatively slowly. So what you can see is a button check tools is pushed or activated with voice commands. And then this is really like a one-time thing, like a one-time detection that is run, and it also takes like 5 seconds. So this would then not be feasible for a pipeline where you would want to check every frame, say. But for this scenario where you check just one single setting of tools, it works. And for other features, you would definitely have to look more into algorithms with a better performance.
So I think Matt wants to say something about too. He was involved in the computer vision team as well.
So the external tool recognition features, meaning with the external camera, that's running on every frame, which means, but we can use that on a desktop computer. So we can perform all the expensive algorithms on a very powerful machine, and all we're sending to the HoloLens are coordinates, basically. So where relative to the camera is the tool located, which is much less computationally intensive for the HoloLens device.
Yeah.
So any other questions in the room, or also? Yes?
Yes.
Thank you very much. During your live demo just now, you showed like the videos displayed above the patient or the simulated patient. Do you think there's also, maybe also from the feedback from the surgeons, some digital content you could display directly on the patient? Like, I don't know, while you insert it, or something like this, like a trajectory, stuff that could help them in the execution, or is it sufficient just to provide information of the steps?
Mm-hmm.
So it seems to be quite sufficient to provide that information. However, you could easily just move the video like on the patient or the dummy, because it looks quite solid in the video, but it's actually quite transparent. So you could actually watch the video here and still be doing something on the patient or on our simulator here. But of course, in a future scenario, there would also be the possibility of kind of recognizing where the patient is. And then, as you, for example, said, project the trajectory where the needle had to be inserted or in which angle, but that really lies in the future for now, because that requires a really robust computer vision algorithm, which also sees the differences like in different people. I think it would first work on our simulator, for example, which is always the same and then could be recognized.
Yeah, I think this will also become more interesting if once the holographic devices, just the HoloLens, become more precise and more reliable, so that you can actually be safe to use this in an operating room. Exactly. Yes, I think we have a question from our live stream.
Yes, there was a question online, and the question is, if the AR system fails, is there a backup system, for example, a separate monitor to assist the surgeon or not?
Yes.
Maybe I can answer this myself. We have several HoloLenses which can be used. They can start up separately. And the special thing about the server is that we can connect it even later and send on the warnings. For example, if the surgeon is assisting or is in the ICU, we can start up the HoloLens, the backup HoloLens, then give the information back on the HoloLens, and they can proceed where they left last within only a few steps. So that's the backup system.
Take some time because the microphone needs to be disinfected.
Well, in your outlook, also you comment a little bit what how this project can be continued, and of course to go in operation, this is from a regulation extremely challenging, because
Yes.
you have to fulfill a lot of requirements to the regulation. But one scenario you pointed out was training. You also commented, so did not show it, but comment that you can have some kind of training report with a PDF. Can you comment a little bit, because I think this is very interesting to have a direct feedback from your behavioral and selections, so and times which are so analyzed during your training.
Yes.
So yes, of course, in the end, in the statistics section, you get like the time it took you for the whole procedure, but you can always go to a more specific display where you can see the times for every step. So for example, if you have if you already have some guidelines from the hospital, which should say, okay, you should have like 5 minutes for that step or 10 minutes for that one. And then you can see, okay, I've had 20 minutes in the one I've had to had 10 minutes for. Then you can see, okay, there is still a problem. We also have the feature that in our intermediate or expert versions, there are information buttons. So in the steps themselves, there is only like the most vital steps listed. And if you want to have the steps with more detailed information, you can click on an information button and the detailed information will be displayed. The statistics section also counts how many info buttons you have pressed and which info buttons that were indicating where you might have still needed help on. So this also indicates a step where a surgeon might have had some uncertainties. And of course, also if they recognize their uncertainties, the flags are marked. So I think it's a really powerful tool to just compare your progress in how much faster you've got, that you had to mark less flags or just call up less information buttons. And I think if the university has some guideline, university hospital, for example, has some guidelines which how surgeons have to be for the procedure, and that displaying in numbers, it's a powerful tool to just enable surgeons to see whether they are ready or not.
Yeah, and I mean, what is also very handy here is that, of course, the HoloLens was made to record the field of view of a surgeon and the field of action, right, where the surgeon manipulates stuff with his hand. So you can, of course, always just record the training session, and this is also how we conducted our study. So we just filmed a trial session, so to say, and then analyzed which tasks were fulfilled with security and others with less confidence.
So first of all, I would say compliments from all the USAID team, because
Thanks.
I
Thank
think,
you.
Aurora has been one of the best team we have worked with
Very much.
in terms of motivation and in terms of the let's say breakthrough technologies brought to the table. I have to say that from what you were talking about before, the training, the Aurora application and the experience that can provide for the people that are going to be trained, it's very wide, because it moves from the training itself, so the learning part of the physicians, and it can extend to the examination side. So it's really bringing on the table a way in which we can evaluate more objectively people that are performing ECMO training. I just want to ask you, in your experience during these last months, which has been the most challenging thing you are facing with, a part of the relationship with the physician team, that we know it's challenging because we had a lot of limitations due to operation room timing, but we also really appreciated your flexibility and your availability of matching our needs in terms of organization. So if you have to look back, what has been the most challenging part of your project?
Yeah, thank you, first of all, for your comments. I think one of the most challenging things from a technical standpoint was definitely computer vision, because there's so much things to consider. For example, the computational performance has to consider. You need to think about what do you actually want to do with computer vision, where do you want to run the calculations so that they perform well enough. But besides this technical difficulty, I think a challenge that was very typical of our project was that we always had to look how can we organize our application that it really makes sense to the surgeons, because after all, we're engineers, we like to try out nice features, but what we do want is to generate useful features and really to wrap up all those features in one application as a product that generates use. That was really something we had to think long and hard about, and we hope that we succeeded in doing so.
There is another question online. And there is a question: what is the status quo in the field of augmented reality surgery assistance? Are there any comparable solutions being developed or by any other university companies?
Yes, there is definitely some work going on in this area. One very common theme is that people try to use the HoloLens to display overlays with patients' bodies. So for example, people are trying to use MRI scans or other kind of medical visual data to overlay it to the patient so that you can, in a sense, look into the patient and therefore make your manipulation. So that is a common theme. And when it comes to training, I think that the HoloLens is also commonly used for training. However, we haven't seen an application that really does what our application does with its combination of really a step-by-step guide and the simulation-based training. So Of course, I don't know of all the work that is going on, but as of now, I haven't seen a similar project.
There is another question online, and that is any opportunity to implement real-time remote proctoring. I answered this question myself. We thought about using telecommunication between a HoloLens and a laptop or a monitor, an external monitor. It would have been too much for our project time, but it's still something that can be done in future. And then a supervision person can sit on a monitor extern, not even in the same room, and can watch what the user of the HoloLens is doing. And therefore, it would be possible to have an external proctoring.
Yes. Are there any further questions? Also for the people tuning in on YouTube. We have a question here in the room.
Thank you very much for your presentation and also the live demo. I really enjoyed it. My question would be, you were talking before about features and about making the relevant features.
Yes.
So what would be the next feature if you had more time to implement?
Yes, that's a very good question. So as I said, making more use of the data is, I think, an interesting field because there's so much to be done there, right? There's so many ways in which you could try to analyze it. And with the current rise of machine learning, this would be very interesting. Another thing for us, I think, would be dynamic tool recognition. Now, in the scope of our project, it didn't quite work out the way we hoped it to. But I think this would really be something that would offer a huge amount of different assistance features in the future. So working more on computer vision and dynamic tool recognition and also usage estimation of tools would definitely be one of the most interesting next things to do. Okay. I think that's it question-wise. So now we will end the live stream. Thank you all for tuning in and for watching our presentation and being interested in our project, really. Thank you very much.
Thank you.